I know it might seem like a long time since last Friday, so just to get that brain warmed up, try to find me the amplitude and the vertical shift. Those are kind of the two values that you can just kind of see. So take a second and try to find those two values. If you need a quick refresh, just flip to one of the other examples.
And is that midline the same as your question?
Mm-hmm. Yep. Awesome. So what were we able to get for our amplitude? Yep, it's just that number right out front, and then what was our K value or our vertical shift? Yep, down 1, -1. Same idea. Yep. So our vertical shift, we see from our K value, since it's negative, that means we're going down. Here is -1, so we go down 1. The vertical shift directly tells us our midline. So that one's always nice. Can anyone tell me what the domain always is for sine and cosine? Yep. Two ways to say the same thing, all real numbers, negative infinity to infinity. Great, so then who can tell me what the b value is here? X over 2, yep. So it's important to remember that we kind of have to separate the b value from the x. So our b value here would just be 1/2. We're looking at the coefficient for x, and this one's a little bit different than any one we've seen because it's x over 2. But remember, that's the same thing. X over 2 is the same thing as 1/2 times x. So then our b value is that coefficient. So our b value is just 1/2. So is that our period? Is 1/2 our period? Nope, it's the value we use to plug into the period formula. It's kind of the key to our period, but it's not our period. So if you remember, the formula for period is 2 pi over b. Here, b is 1/2, so we can keep, change, flip it. 2 pi times 2 over 1. Run out of space. Gives us the period is 4 pi. Does it make sense how I was able to do that? If I plug in b to 2 pi over b, then it's 2 pi over 1/2. The way we can divide fractions is keep the one on top, change it to multiplication, and then flip the one on the bottom. Yep.
What was the equation used again? Was this that flip in the parentheses plus the row?
Yeah, so that'll be horizontal shift. We're getting there. We're getting there. So our period here is 4. Next thing we're looking for is our horizontal shift. Horizontal shift, like Kimmy said, you take what's inside the parentheses. Here it's x over 2 minus pi, and you set it equal to 0, and then you solve for x. So what's the first thing I should do? Should I multiply both sides by 2, or should I add pi to both sides? Add pi to both sides, yep. If you're a little bit unsure, you want to work outside in when solving an equation. A little bit of algebra review. First thing you should do is add pi to both sides. That gives you x over 2 equals pi. Next thing I would do is then multiply both sides by 2. That's going to give me, x equals 2 pi. Since that 2 pi is positive, it's not negative, and we're talking about our horizontal shift here, is it going to be moving right or is it going to be moving left? Right, yep. When horizontal shift is positive, it moves right, moves in the positive x direction. When horizontal shift is negative, the whole thing's going to move left. So here our horizontal shift is going to be right by, what was it again, 2 pi? Awesome.
So if it's right by 2 pi, is that
Yep, so we're going to talk about it. So what's the scale we've been using?
45?
Yep. The scale we've been using is 45 degrees or pi over 4. Thank you, Georgia. Oh, yep. But the reason we leave this unlabeled is for situations like this where we need to adjust the scale. Because real quick, if we didn't adjust our scale, then the first hash mark we're going to plot is the horizontal shift, or just the positive 2 pi. That would be 1, 2, 3, 4, 5, 6, 7, 8. Our first tick mark would be right there. And then the end of our first period would have to be 4 pi to the right of that. We would be way off the screen. There's not enough room on this coordinate plane to graph that. But the nice thing we can do is we can adjust our scale. So what we're going to do here is, instead of having our scale be 45 degrees, we're going to change it and make our scale 90 degrees. Yep, exactly, or pi over 2. So make sure you write that in. It's really important, especially if you're not using the 45 degree scale, to make sure you notate it in so everyone is on the same page with you. Yep, so every 2 dashes is 1 pi, or every dash is half a pi. So now that we're doing that, how many to the right of the origin is 2 pi? 4, yep. 1, 2, 3, 4. Right there is going to be my starting point. Remember, your starting point is always your horizontal shift. So if your horizontal shift is x equals 2 pi, that's where you need to start. Our scale here is 90 degrees, or half a pi. So half a pi, 1 pi, 3 halves pi, 2 pi. That's going to be our starting point. After you get that first hash mark, the next thing you want to do is go 1 full period in the positive direction. Here, how long is a period? 4 pi, yep. So how many spaces is that going to be? If each space is half a pi. What? It would be 8. Does that make sense why? So our scale here is 90 degrees or pi over 2. So every jump increases by 90 degrees. Our period is 4 pi, or 720 degrees. So if we're making jumps by 90 degrees, it's going to take 8 jumps to get all the way to 720 degrees. So we have to extend our graph out a little bit. We still don't have quite enough room. I think that should do it. And then there, we count off by 8, or we count off by pi over 2, starting at our start point until we get to 4 pi. So it's going to be pi over 2 if you're looking at the board. pi over 2, pi, 2 pi, 3 pi, 4 pi. So that right there is going to be the endpoint of our period. Now that we have that, we kind of follow the same procedure. First thing we do is we find the middle dash. Here, that's going to be right there. And then we find the middles of the middles. And the end result is we should have 5 evenly spaced dashes. Does anyone have any questions with that? One way to kind of think about the change in scale is like you're using Apple Maps or Google Maps and you just zoom out. That's essentially what we were doing. We had to zoom out to make that whole graph fit on our picture. So now that we have our 5 dashes, we can start graphing. And the parent function here is sine. So does sine start on the midline or does it start at the top? Midline, right. And we know that it's going to be at the midline at the beginning of the period, at the end of the period, and at the middle of the period. So I'm not even going to write the k plus a, and k minus a pattern here. If that helps you, I would encourage writing it for every problem. But I'm just going to plot the points. We know it starts on the midline, and our midline is y equals -1. We know it ends on the midline, and we know at the middle it's on the midline. Then we know that the amplitude is 3. So the amplitude is the difference between the midline and the high point, and the midline and the low point. So we know it's going to have a high point on that second hash mark. So what I'm going to do there is I'm going to go up by 3 because that's the amplitude. And that's going to be my point. And then on the last remaining hash mark, I know that's going to be the bottom or the k minus a. So I'm going to go down by 3 hops, and that'll be my bottom point. Oh, it's deleted. Yep.
How did you know to start off high again?
Yeah, so that's just kind of remembering the sine pattern. Sine always, it goes medium, high, medium, low, medium. If you have trouble remembering that, I would just remember the pattern of k, k plus a, k minus a, and then k. And that's what we wrote out for all the examples up until now. So now that we have our 5 points, we can graph them. Looks something like that. And now we have 1 period, but when we ask you guys to graph, we want to see 2 periods. The quickest way to go to make another period is just to go in the negative direction. The way we would do that is we would make 4 hash marks with the same spacing that we already established. That spacing is that we're going to have to make a tick every other. So that's going to be 1, 2, 3, 4. And then from there, in the negative direction, we still know at the middle and the end, sine's going to be on the midline. So I'm going to graph those 2 points first. And then from there, we know the midline points act kind of like a teeter-totter. And so if you're wondering if you need to go up or if you need to go down here, just think of it like that. You don't want to break the teeter-totter. So then that means that we have to go down. So that hash mark is going to be at the bottom point, which is going to be 3 down from the midpoint, midline. And then the remaining hash mark's going to be a high point. So we graph that. Then we connect the points, and then that's 2 full periods of the function. Last but not least, please don't forget this on your test. We're asking you for the range values. Here, the range values, the smallest y is -1, -2, -3, -4. And the biggest y is +2. Don't forget the square brackets. If you draw just like the soft parentheses, you'll be wrong. Does anyone have a question with changing the scale or anything I showed you for example number 5.